purpose of this video is to share with anyone who might be interested one man's solution to a grid-free source of water for the residents. This is the outside of the well house. This was all put into service in 2013. Of course, over the years it's been upgraded and I've made changes here and there. What you see now are the REC Solar 450 watt panels. They're Alpha72s. They replaced some sharp 250 watt panels that over the years just couldn't provide the needs that I had. On this lower right corner of the roof eave, that is an Ayrmesh receiver that brings the home's Wi-Fi out here so that I can monitor the charging. And then a photo cell, which is also connected to my charging system. I'll just take a moment and pan around so that anyone who's interested can see. If they have any questions, of course, they can always put them in comments. Got my battery system down there. That is a booster pump. That is a SimplePump, which was the very first well pump I started with. Later, I upgraded to a submersible Grundfos SQFlex pump. Initially, there was no inverter. It was all DC 24 volt just for the SimplePump. And then when I added the Grundfos pump, I added this Schneider ConextSW 4,000 watt split phase pure sine inverter. And of course the control box with it. This was original to my setup, the TriStar MPPT-45 charge controller. It's been working fine ever since it was installed for the last 9 years. That is an interconnect box that allows me to look at the internet and see what the charge controller is doing, and that's why I have the Ayrmesh receiver out there. It connects to the receiver, Wi-Fi is back to my house network, and then I can view the status of the charging. And let me see if I can show this to you on this iPad tablet here. Forgive the... And so that is the current state of everything that's going on right now. And I can view this in the home as well as anywhere on the property. It does not feed to the internet. If it does, I don't know how to do that. I don't want to do that anyway. So, the thoughts behind this system when I designed it, I wanted it to be an apocalypse well, which is a little overkill, and over the years I've seen that. I chose the SimplePump because it can be pumped manually if need be. And I chose to have a storage tank at the top, which explains why my roof pitch is so high, which is not really the correct angle for the solar panels at this latitude, but it has worked well. My idea behind setting it up like that was in case I had a total loss of power, solar panels, any electrical failures, then I could manually pump the head tank and then let it gravity feed down and gravity feed to the house. It wouldn't give you any pressure per se, but it may at least fill a toilet tank or give you a dribble out of the sink so you don't have to carry buckets of water around. At least that's the thought anyway. I've never tested it, but that's why it was built this way. Then that is the booster pump. So it draws water out of the head tank and sends it to the bladder tank, which is located in the original well house, to the house when we bought it. This one is set for 60 psi cutout and 40 psi cut in. This is the control panel. It did not start with all these buttons and switches on it. That's been developed over time. Originally, it just controlled the SimplePump. That is the interior. At the top is a low voltage cutout, which I put in there in order to prevent discharging the batteries too low. I set it at a high threshold so that I don't cycle them too much. So far it's only cut out twice, and that was years back before I changed the solar panels. The two white things are the contactors, one for controlling the boost pump and one for controlling the SimplePump. They came from Germany actually. They use them on subway equipment because they're rated for 1 million cycles. Well, that was my plan. And then of course the inverter here, the Connext Schneider, 4,000 watt with only like 3,400 watt continuous, 24 volt split phase pure sine with the control panel. That was added 2 years ago in order to power the Grundfos submersible SQFlex pump. That's the control box for that pump. It's not necessary for it, but it's just another little feature that lets me monitor it and see if there's any errors with it. I did have to add that little bladder tank down there because we're so far away from the main bladder tank that when the high pressure was reached, the water hammer effect would cause it to just continually cycle, and that solved that problem. The boost pump itself is an Oberdorfer. Bought it off of eBay. And it has a helical rotor, which I chose that because it would be less likely to wear out over time if there was some sand or other mineral deposits in the well water. And the Grundfos submersible pump is also a helical rotor. And if you haven't looked into the SQFlex, SQFlex, that particular pump is able to run on AC or DC. It doesn't, you just hook it up, and whatever you feed it, it will determine what you've got and run. Now, it runs based on the amount of voltage you give it. So it'll run, I believe, 30 volts to 200 and 300 volts DC, or 90 volts to 300 volts AC, something like that. You'll have to look up the specs yourself. But you don't have to do anything special to transfer it from AC or DC. So in order to get the most out of it, though, I chose to run it on AC, and that's why I chose to add the inverter so that I can get the maximum flow rate out of it. The way I've got it set up, I can get 50 psi at 6 gallons a minute. I do have grid power available in this well house. And so when I added the inverter and the SQFlex pump, I just decided to add a transfer switch here so I can run that pump either straight off the grid or totally off of the power generated here in the well. And since I put the new panels up outside, I have not had to do any changeovers. In that box is another complete booster pump, motor and pump together. The motor is 24 volt DC, bought it off of eBay as well. Pacific Scientific, 1/2 horsepower. Works well. I control the pressure with these transducers here. I'll have to cut it later. They're mechanical transducers, and they can be adjusted for pressure. So I've got a high pressure and a low pressure transducer that feed into the control box. I'll go ahead and run the system. First we'll do a boost, a manual boost. And you can see what the pressure is going to do down here. It's already at 60. So we should shut off pretty quick. There we go. You see the water hammer swinging the needle back and forth, and that's why that little bladder tank was added to prevent that. And then the well pump itself, I've got it set to run on the Grundfos pump right now. I've had the SimplePump turned off. So we can start the well pump, And when I start this, what you'll notice is I've got two screens. The inverter will actually show how much power it's providing, and the SimplePump of the Grundfos control box will also show how much power is being used. They don't match, so I don't know which one's correct. So I'm going to go ahead and start the pump. And so you'll see this bar begin to move across, showing the power being consumed. If I can't tell if I've got a glare on the screen or not. And then of course down here, it's showing about 470 watts, and the green LED showing the flow of the water. Oh, there we go. This says about 300 and 400 watts close. Now what's happening is the pump, of course, is this line right here. Goes up into the tank, and there's a level switch up in the tank. It's made by Dwyer, D-W-Y-E-R, and as it fills up, it will shut itself off. So while that's occurring, the reason we went from the SimplePump is it served us well from 2013 to 2020, about 7 years. I did wear out an oil seal in it, and it leaked, and they were gracious enough to fix it for me. I bought a spare motor to have as backup. I've gone through a couple of sets of brushes on this motor. The reason is the SimplePump, although it's a great pump and I really liked it, but for our purposes over time, we discovered it didn't quite serve our needs because it only pumps about 1 gallon a minute. And just for my wife and I, that's fine. But when my wife decided she wanted to water the yard in the summertime, it couldn't keep up, and our standard electric original well pump would have to cut on. So that's why you see it sitting the way it is now. It used to sit lower in the casing. I had to raise it up to make room for the Grundfos pump. It's still connected. It can still run. I just don't have a need for it. I'll run it occasionally. The Grundfos is doing a fine job, and we're very pleased with that. Just information about the well itself. It's 85 feet deep, 4-foot, 4-inch casing. The water was at 45 feet, I believe the driller said when he drilled it. All this was information about the charge controller. These are the schematics that I hand drew just for the components I have in the control box there. The low voltage cutoff relay, well pump control, and then the booster pump control on the other side. I'm sure I'll get some criticisms. This is the very first YouTube video I've ever made. I had no desire to even share this with anybody, but over the years I felt as though perhaps with the times that we're living in, there may be some other people interested in what I've done, and because there's plenty of videos out there of solar wells, so this is just one man's take on it. Did get this building spray foamed. And that has been a very big help in the winter time. It doesn't get cold here very much anyway, but on the days that it does, that little bitty ceramic heater, I'll just plug it into grid power, and it keeps this room warm. And even without it, it doesn't get cold enough to harm anything. That's just me being proactive. And so if you have any questions, feel free to leave comments. Hopefully you'll be generous to me, or at least forgiving, and anything I may have forgotten, I'll certainly try to answer for you, just to help somebody do what I've done.